We're going to move on today to looking at the sum of angles in an interior angles in a polygon. So we looked yesterday at interior angles on the inside of a 2D shape with straight sides. The sum just means the total of them. So yesterday we looked at the fact that we could use the interior plus the exterior equals 180 as they are on a straight line, and we knew that our exterior angle, just one in a regular polygon, is 360 divided by n, so that's just for a regular polygon. We're going to use those formulas now to help you to do the warm-up. So if you haven't already, can you please pause that video and make sure you've given those a go. Alright, so we actually have some parts of these answers already. We needed to find the interior angle, so we need the exterior angle to help us with that. But these are the exact same ones that we calculated yesterday. So our exteriors came from yesterday, 360 over 12, 360 over 25, 360 over 32, and 360 over 80. That gave us 30 degrees, 14.4 degrees, 11.25 degrees, and 4.5 degrees. Our interiors therefore are going to be 180 minus 30, or 150. We actually saw this one twice yesterday. 180 minus 14.4. So we're going to end up with 165.6 degrees for this one. Our next one is going to be 180 take 11.25. That's going to get us 168.75. We're also going to have 180 minus 4.5 degrees, which is going to get us 175.5 degrees for that last one. So again, not nice round numbers as what we're getting as answers, but they are fully acceptable. So what we're going to do today is move on to finding the sum of interior angles in a polygon. It can be regular or irregular, so we're actually going to flip our approach a little bit and see if we can do something different. We could do what we've done before and treat it as a regular polygon, find its exterior, one interior, and then multiply it by the number of sides. That would be a perfectly acceptable way to do it, but I want to try something a little bit different. What I'm going to do is I'm going to split this shape up into smaller shapes that I already know about. I'm actually going to go for triangles because I know that the sum of the interior angles here is 180 degrees, just like those straight lines that we use for interior and exterior angles. So I'm going to pick a vertex to start at, it doesn't really matter where that is, and I'm going to draw straight lines from that vertex to any of the others that don't already have them. And I've split this into 3 different triangles. So I've got 180 degrees here, 180 degrees here, and 180 degrees here. So in total, I am going to end up with 540 degrees in a pentagon, because I know that it has 3 triangles within it. I'm going to challenge you to try and do the same for these ones. Can you give those a go now? Okay. Again, I'm just going to pick a vertex, it doesn't matter where it is, and connect it up to all of the others where they are on already. So one here, one here, and one here. So my hexagon has 4 triangles, each one of those worth 180 degrees. So I can do 4 times 180 degrees, to get us 720 degrees in total. If we were to look at an octagon, I'm going to pick a vertex to start at. Let's go for this one this time. And split this up. So my octagon has 1, 2, 3, 4, 5, 6 triangles in it. So I'm going to do 6 times 180 this time. 6 multiplied by 180 gets us 1080 degrees. So the sum of the angles in here is something we found. This actually also means we could now work backwards from this to find our interior angles a different way. So if they're regular, I can now divide by n to find one interior angle. And that would give us the same answers that we got last lesson. So here, if I did 720 divided by my 6 sides, so 720 divided by my 6 sides gets me 120 degrees. If I did the same with my octagon and I did 1080 divided by 8, then I would end up with my 135 that we found last lesson. So actually, this is working in kind of conjunction with the things that we already know. It's just an alternate way of thinking about it. What I'd like to do now is try and find a way to find some of the angles if we had, for example, a 35-sided polygon. Would that be an easy thing to split up? Probably not. So what we're going to do is try and see if there's a pattern we can spot instead. So I'm going to start a table and I'm going to put a polygon with a certain number of sides. I'm going to put the number of triangles, and then it's going to be 180 times the number of triangles to get my sum of my interior angles. So if I was to start with the number of sides being 3, we know this already has got 1 triangle within it, and therefore we've got 180 degrees. We haven't considered a quadrilateral in any of our calculations yet, so if I was to draw, I'm going to start with a rectangle and split it up by looking at one corner. I would end up with 2 different triangles, and I'm hoping you can see that that would also be the case for any other quadrilateral. That's going to get me 360 degrees inside that quadrilateral, which again might be a fact that you already remember. We've just worked through 5 sides, or a pentagon. There were 3 triangles in there, which gave us 540 degrees. And then we did a hexagon with 6, which gave us 4 triangles on the inside, and then a total of 720. We skipped 7, so I'll come back to that in a second, and did 8 instead. The 8 was 6 triangles, and that gave us 1080. There are lots of different patterns here, absolutely tons of them. So I'm hoping that you can see the number of sides and the number of triangles goes up by 1 every single time. We're just going to confirm that with a 7-sided shape. I'm going to try and draw one. I'm not particularly great with them, but we'll start with roughly an octagon. 1, 2, 3, 4, 5, 6. Let's go 7 across there. So I'm going to start with this vertex that isn't particularly well drawn. I've got 1, 2, 3. Oh, I've drawn a hexagon, that's why. Let's try again. Right, not a regular one, but it'll do. I'm going to start here. 1, 2, 3, 4, and 5 in there. So this 5 is my number of triangles. I'm going to do 5 times by 180, which is going to get me 900 degrees. Really what we're looking for here is a formula and a way to come up with a pattern. So we've previously used n sides as what's been going on here. The number of triangles, what's the relationship between the number of sides and the number of triangles? So how do I get from here to here every time? Hopefully you've noticed that I have to take 2 every single time. And so my formula becomes n minus 2 times 180. This is the formula that we need to remember for the sum of interior angles. That's n minus 2, the number of sides minus 2, multiplied by 180. So that is our key formula for today. So let's go back to the pentagon and use that formula. We actually knew from before that we should get 540. So our pentagon n is 5. This means I'm going to do 5 take 2 times 180, or 3 times 180, which gets us 540, exactly like we got before. Your challenge now is to try these ones. So if you haven't already, pause the video and then we'll go through some answers. Okay, so we first got to figure out what n is in every single case here. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 10 sides here. So we've got a decagon. So in my decagon, I need to do 10 minus 2 times by 180, or 8 multiplied by 180. 8 multiplied by 180 is going to get me 1,440 degrees in a decagon. We've already kind of answered this one before. It's a much better drawing than the one I went for. So we've got a 7-sided shape. That's n is 7. If we're looking at our table from before, we should have done got 900, but let's just verify that. So we're doing 7 take 2 times 180. That's 5 times 180, which is 900. Last but not least, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We've got a dodecagon. So a 12-sided shape. That means that we're going to do 12 take 2 times 180, or 10 times 180, which gets us 1,800 degrees in a dodecagon. The only thing left for you to do today is to make sure that you have had a look at the Hegarty Maths clip 561. So make sure you've got at least 70% on that, and that you are ready to kind of tackle any of the more difficult problems we throw at you towards the end of the week. If you want to try any more of the associated clips around this, please feel free, and let us know how you're getting on. Unless you've got any issues and need to email us, stay safe and we'll see you tomorrow.